we have three circles, and intermeshed in there is a triangle. And the idea is to figure out the angles of the triangle and the relative lengths of the sides of the circle. So let's do this. So I'll redraw the triangle here because otherwise it can get pretty busy in the diagram. Okay, and now between C and B, okay, we'll make that our unit length, because when we're dealing with relative sizes, we get to pick a unit, and this is the one that's going to work. So BC, that's our unit length. Now, BC is the radius of this circle centered at B, okay? And another point on that circle centered at B is D, conveniently located. So I draw this line right here. That's the same as BC. So that circle has done its duty. That's D. So this is also a unit of 1. Okay, now D is the center of this circle that has B on it, but also A. So that tells me that AD also has a length of 1. So there's our 3 unit lengths hidden, so to speak, inside the triangle. Finally, A is the center of a circle that has C and B on its circumference. So that means that AC and AB are the same length. So let's call this unknown X. It turns out to be only one unknown, and so this other side is going to be X plus 1. So we've got an isosceles triangle. Now that we're done with the circles, we can just focus on the triangle. The circles have done their job. I want to point out, since this is an isosceles triangle, this angle and this angle, the base angles are the same. But better than that, we have got another isosceles triangle. This one here with the 2 1s. Okay? 2 sides are 1, which means its base angle, this and this, are the same. So now we've got 3 instances of that same angle, but it gets more fun. This skinny angle here, A, it's the same as this skinny angle here. Why? Because we've got another isosceles triangle. We've got the one here and the one here. So it's a wider isosceles triangle with skinnier angles at the base. So we basically got 3 isosceles triangles. But the thing to notice here is that 2 of them are similar. And that's the big triangle that we start out with, ACB. That is similar to this on its side triangle, BDC. Okay, they're similar. They've got the same base angles, C and B here, and D and C here, which means angle A is also equal to what I've labeled here as B, but that's this skinny angle right here is the same as A. But we also said that this angle was the same as A. So what's happened here is that this line right here, and I'm making a huge mess of it now, this line here, it bisects this angle B. So what we've determined here then is that this angle here, which we'll call theta, is half the base angles, each of the base angles. And same thing, of course, with the similar triangle. Okay. Now, we know the angles are going to total 180 degrees. Okay, so 180 degrees is equal to theta plus 2 theta plus 2 theta, which is 5 theta. So theta can only be one thing, 36 degrees. Okay? So this is 36 degrees up here. This is 72. And this whole thing here is 72. That little thing in there is 72. And that little thing in there is 36. Okay. So we've got the angles sorted out. Now let's work on the relative sides. Since we have two similar triangles, we can make a statement about the relative proportions of their sides. So we've got x plus 1 is to 1, the side is to the base, as the side 1 is to the base, x. So x plus 1 equals 1 over x. So let's cross multiply. So 1 times 1, oh, got to work that out. Okay, that's going to be 1. And then over here we've got x plus 1 times x. And that equals 1. So now we've got what's going to work out to be a quadratic, which we can solve. So let's expand this. We get x squared here plus x, and then we'll leave this 1 here because we're going to complete the square. So what do we need to do to complete the square? We need to take a half of this invisible 1 here, and we need to add the square of that, which is a quarter, and then over here on this side we'll add a quarter. Okay? And so now we have here x plus a half squared equals 5 quarters. Just putting that 1 and a quarter together. And now we'll square rootify this. X plus 1/2 equals the square root of 5 over the square root of 4, which is 2. And let's bring that 2 over to this side. And finally we have x equals negative 1/2 plus square root of 5 over 2. Now the solution to the quadratic also includes minus the square root of 5 over 2, but that would give us a negative number. We're just going to take the positive solution because that's the one that helps us with this. So going back to our original thing, we can summarize this angle here is 72. That angle there is 72. Over here we've got 36. And if we take the base as being 1, then this side here is going to be negative 1/2 plus square root of 5 over Bob's your uncle. Click things, subscribe there, and video there.